Hello dear viewers, I am Khan Bahadur, Assistant Professor of Statistics, and you are watching a video from my YouTube channel Statistics by Khan. Dear viewers, I hope all of you will be doing great. Dear viewers, this YouTube channel Statistics by Khan has been created for basic statistics with a view to help the beginner students of statistics, the researchers of all fields, and other learners of basic statistics. I have also a Facebook page and group with the same name, Statistics by Khan. You can visit them for steps related to basic statistics. Dear viewers, for better understanding of concepts in my video, I would recommend you to watch the full video. After watching the full video, I assure you, you will understand the concepts very clearly. In today's lecture, we are computing mode from continuous group data or from continuous frequency distribution. So let's start the lecture. Mode from continuous group data. As in the last two lectures, we have found mode in case of individual data and secondly in case of discrete group data. Over there was no need of any formula or any computation. In individual data case, only by counting we were able to find the mode. In discrete group data, from the frequencies we were finding the mode, that is, the value of the variable against the maximum frequency was the mode. But now in this continuous group data, first of all, we will find the model class on the basis of the class frequencies. That is, a class against the maximum frequency will be the model class. And then we will interpolate a single value in that model class. So for this purpose, we will need a formula for the interpolation and hence we will need a computation as well. So let's take a numerical example in order to make the mechanism clear. So let's take a numerical example. So this is the example. Compute the mode from the following continuous frequency distribution. This is the continuous frequency distribution. And now we are computing mode from this frequency distribution. So in computing the mode from the continuous frequency distribution, the first step is to find the model class. And as I have told you before the start of this example, that a model class is a class against the maximum frequencies. So these are the frequencies. The maximum frequency is 304 and the class against this frequency is 60 to 69. So this is the model class. This 60 to 69 is the model class. Now, as mode is a single quantity measure, but this class contains infinite values. So that is why now we will interpolate a single value from this class. So for this purpose, we will use a formula for interpolation. The formula is, so this is the formula for the interpolation of model value from the model class. Now, if we look at this formula, so this S stands for the lower limit of the model class. So again, in the formula, we are using one of the limits of the model class itself. So that is why now we will focus upon the classes, whether the classes are class limits or class boundaries. Because whenever we are using the class limits themselves in the formula, so then in that case, we are needed class boundaries. So now in this specific case, if we look at the classes, so these are class limits, not class boundaries. So for this purpose, now we will transform these class limits into class boundaries. We have already discussed these technicalities in the computation of median from continuous group data. We have discussed there that when we are transforming class limits into class boundaries. And we have also discussed that how to transform class limits into class boundaries. So here on fast track, we will compute the class boundaries. That is, the procedure for transforming class limits into class boundaries is that the upper limit of the preceding class will be subtracted from the lower limit of the succeeding class. That is, 39 will be subtracted from 40 and that difference will be divided by 2. So if we subtract 39 from 40, we will get 1. And if we divide that 1 by 2, so we will get 0.5. Similarly, if we check the same procedure for the next class, so in the second and third class, what we will do, we will subtract the upper limit of the second class from the lower limit of the third class. So in this case too, if we subtract 49 from 50, so we will get 1. And if we divide that 1 by 2, so we will get 0.5. And the same is the case for the rest of the classes. So therefore, what we will do now, we will subtract 0.5 from the lower limit of each class and will add 0.5 in upper limit of each class. That is, we will subtract 0.5 from 30, so we will get 29.5. And we will add 0.5 in 39, so we will get 39.5. Similarly, we will subtract 0.5 from 40, so we will get 39.5. Similarly, we will add 0.5 in 49, so we will get 49.5. And if we proceed the same way, we will get 49.5 and 59.5, 59.5 and 69.5, 69.5 and 79.5, 79.5 and 89.5, 89.5 and 99.5. So now we can see that these class limits have been transformed into class boundaries, as there was no match between the upper limit of the preceding class with the lower limit of the succeeding class. But over here, now the upper limit of the preceding class is exactly equal to the lower limit of the succeeding class. So when there is no match between the upper limit of the preceding class and the lower limit of the succeeding class, then such classes are called class limits. And when there is match between the upper limit of the preceding class and the lower limit of the succeeding class, then such classes are called class boundaries. Whenever we are using any one limit or both limits of a class in the formula, so then in that case, we are transforming class limits into class boundaries. So that was the whole logic behind this transformation. Now we are focusing upon the formula. Now this L has become the lower limit of this model class boundaries. So the lower limit in this class is 59.5. So therefore L is equal to 59.5. Now this FM shows the frequency of the model class, as this is the model class and this is the frequency of the model class. So FM is equal to 304. This 304 is FM. So we will write 304 over here. Now, what is F1? F1 is the frequency of the class preceding to the model class. So, this is the model class and this is the preceding class. So, the frequency of this class is F1. So, this is F1. So, F1 is equal to 190. We will write 190 over here. Now, in the denominator, here is again Fm minus F1 as it was in the numerator. So, we will again write the same quantity in the denominator. Plus, now here Fm minus F2, as Fm is the frequency of the model class and this frequency is equal to 304. So we will write 304 over here. Minus F2. F2 is the frequency of the succeeding class, the class after the model class. So this is the succeeding class and this is the frequency of the succeeding class. So this will become F2. F2 is equal to 211. So we will write 211 over here. So in the next step, this will become 59.5 and if we solve it, so we will get 5.8. And in the final step, we will get 65.3. So this is the mode of this data set. The model marks are 65.3. So 65.3 means that 65.3 have been taken by many students or 65.3 have been taken by 304 students. So this was the computation of mode from continuous group data. I hope this will help you in the computation of mode from continuous group data. Thank you for watching the video.